professors, TAs, and students. Today I will be presenting our Comprop final project, Student Data Analysis and Visualization System. So the objective of our project is to create a Python program that reads and analyzes student data from a CSV file, generates statistical summaries, and finds the correlation between variables and visualizes academic trends. So as for if our project meets the requirements, we have the code both on Google Colab and on Fonny, but I will be looking at it in Fonny because it doesn't have the annotations. Yes, it exceeds 100 lines of code. There are 181 lines of code excluding blank spaces. It has more than 5 functions. It has 23 functions. And as for if it meets the if else loop list tuple set string requirement here. So here's where a list was used. Here's where a dictionary was used. Here's where we use a set that is packed within a tuple, and this tuple is then unpacked here in the following. And as a disclaimer, yes, this project was assisted using AI, and here are some of the clear examples. We wanted help with implementing the menu function, so we asked how to use the main Python function, and here is when AI suggested to use this as a tiebreaker code for when we are doing the scholarship cutoff. And here is another instance of when AI was assisted. Is they suggested using this instead of get key because it helped make the code run more efficiently. Here I will show how the code works in Google Colab as well, because I was just using the Fonny file so I can scroll through the code faster. Here you select option 1. You can look at the top. It gives you the top student with their SID and their GPA. And as you can see, it just works the same here. And next we have the GPA menu. And as you can see, there are subcategories: average GPA or average GPA by major, GPA categories, and back to menu. And as you can see here, it gives the average GPA, and this is the average GPA by major. Oh, I forgot to show the data set we used. Here's the data set. There's the SID, the gender, the major, the GPA, the hours spent studying, and the hours spent sleeping. And this is what we're going to analyze in our project. And as for the GPA categories, is just to see if how the GPA is distributed. Most of them are average, and it is defined. And it is defined here. So excellent is more than 3.5, good is more than 3, average is more than 2, and below that is considered poor. And here's the more interesting code, scholarship check. If you enter one like a SID you want to look at, it will tell you if the student qualifies for a scholarship and the cutoff GPA. And here are the qualified SIDs grouped by major as well. And as for menu 4, we also create an analysis on we average the number of hours spent studying by gender. So here's female and male, and hours spent sleeping by gender. And as for save summary, this is when it outputs a file. As you can see here, if I check my folder, there's going to be the summary, and in the summary is the total students, the average GPA, the top student, and their GPA. And finally is the correlation graphs. As you can see, there are 5 menus: major and gender distributions, GPA by major, correlations between GPA and study hours, GPA and sleep hours, and study and sleep hours. So here are each of the graphs. There is the pie chart for the major distribution and the gender distribution, the box plots for the GPA by major, so we can see the distribution as well, and the correlation graphs for GPA versus study hours, GPA versus sleep hours, and study hours versus sleep hours. Thank you for listening to my introduction, and I will pass it on to my group members to explain the code.
Hi everyone. Today I will explain our code from step 1 to step 3. The step 1 is import module library. As you see, we use a full library which is pandas, Seaborn, Matplotlib, and NumPy. The step 2 is a reader file. We create a function which load a CVS with pandas. When the script is run directly, it loads the CVS to D. And the third one is a graph helper function, which is like a function with we will display a graph. And see this one, you have to put a title, x label, and y label into run our function. This one is a function that will create a pie chart, and the pie chart didn't need a y label, so we have this one. This one is make our data into a percentage, and the series is the column of our data, like a category. And we also can create a scatter plot, which show a scatter plot and linear regression trend line. The scatter plot and box plot have to call a show function that we create both.
So next is section number 4, which is basic GPA and student analysis. So we're gonna create a top student function, which is trying to find the highest GPA of all students. So we're starting with using df.max to find the maximum value, the maximum GPA value, and then we use a Boolean indexing to filter the data frame. And in the end, we're gonna print out the top student GPA and student ID. Next is to find a GPA of all students, which is quite simple. We just use a .mean command, which just automatically gives us the average of all students, and we're gonna return it. Next is average GPA by major. Now, we're gonna use a command called group by to like only select the major column, and then we're gonna also use a .mean command to find the average, and lastly we're gonna convert it to the dictionaries because it's easy for iteration and format printing, and then lastly we're gonna return the result. Next is a GPA categorize, or like to classify each student GPA into categories. So we're gonna start by using the command iteros, and then we're gonna for loop in it, and then we're gonna give it some conditions. For example, like if GPA more than 3.5, you're gonna get a result of excellent. If you're more than 3, get good. More than 2, average. And then else gonna poor, like if we're lower than that. And in the end, we're gonna print out and return the categories. The next section is fifth section, which is distribution and GPA by major. Like it's a graph, mainly graph visualization. So we're gonna start with first two, which is major distribution and gender distribution. It's just the same coding, it just separate the categories, not the same categories. So we're gonna use a .value counts command on the major and column and gender column to like get a raw count for each categories. And we're gonna plot a PLT. No, I mean I plot a pie chart. Sorry, plot a pie chart. And then we're gonna also include a auto PCT equal that. It's a to give a value in a percentage value. Now we're gonna get a start angle to be 90 because it's the cleanest visual for like starting point. It's easy to look. And lastly, we're gonna plot the title, and we're gonna show the graph. Next is display GPA by major. It's just a compare the spread and central tendency of the GPA of our major. That's it. So we're gonna start by now. We're gonna use Seaborn now. It's gonna be SNS. The command we use is SNS.plot, which is like comparing the distribution across the different categories. And we're gonna use a key parameter to be X a major, Y GPA, HUE a major, and paddleity gonna be set to. We're gonna disable the legends for now. Then we're gonna show graph as the same as the last one. Now, next section is the sixth section, which is correlation and regression. We're gonna find the relationship between these three variables: studying, sleep, and the GPA. So first, we're gonna start with a GPA and hours spent studying. So we're gonna use a command called sns.regplot. Not the same as the last one. The last one is block plot, like this one we're gonna use regplot. And we're gonna give it some key parameters. X equal hours spent studying, Y equal GPA, and scattered KWS. The alpha 0.6 is just a transparency of the graph. Yeah. And lastly, we're gonna show the graph and return it. And next is relationship between GPA and hours spent sleeping. So it's just the same as the last one. Just find the variable of these two. Use the same command, regplot. X equal hours spent sleeping, Y equal GPA, and the same as the last one. But in this one, we're gonna add a color purple to it to make it different. You can separate which graph show what. And lastly, we're gonna end up with sleep and study the variables. So it's just the same as the last one. It's just hours spent sleeping with hours spent studying. And you also use regplot. X equal hours spent studying, Y equal hours spent sleeping. And in this case, we're gonna use a color green to separate the graph. And we're gonna return it. And thank you.
Okay, so Good morning, everyone. Now let's continue. If we finish from the step 1 to step 6, there's still 3 more functions left that we need to do. The first one is the scholarship check. The second one is study and sleep by gender. And finally, the save and summary. Before we combining all of these together and get a full program functions. So let's start with the uh, scholarship check. This scholarship check, first we need to know and we need to create a function to determine the GPA cutoff for the top 15% of students. So we get the number of students right here, and now we use numpy.cell to round up, and we use max with the integer of 1 to make sure that there will be at least one student who's gonna get this scholarship. And then this number is a 0.15, it's indicate the 15% of the top students. Yeah, and this number can be changed into the decide whatever percent or top percentage you want. Now, after you finish, the students will be ranked by GPA as the highest first and to the lower one, and then the student ID from the 001 to more to 002 and more in the ascending order. And then we get the GPA of minimum for those who get the scholarship as a GPA cutoff for scholarship, and those students who's gonna get the scholarship. Now let's move on to this one. This one is the scholarship check to determine these functions. The user would need to type in the student ID like this. And once the student type like this, and once we type the student ID, you can see in the database, I'm sorry, in the output, it says scholarship cutoff is 3.41, and the student does not qualify. And if you look in this here, right here, say these students got only GPA in 2.79, which is of course not qualified. We do that by creating these functions. We check whether the student is in the data frames or not. We call out the functions that I mentioned earlier and print out whether the student is in the top in the list of top students who's gonna get the scholarship or not, as you could see. So now let's move on to the last part, which is group by major. We group the student by major and iterate to the data frame is low. We need the major of each student who's gonna get the scholarship, and then we creating the group and append the student ID to those group. And here, as you could see, it creates the create interface like this. And finally, the sleep aggregations by gender. This function is pretty easy. We just divide or separate the data by gender of the students, and then we find the average or means of the hours spent studying and hours spent sleeping. So here, what this look like, as you could see. And now into the generate summary file. This one is just a pretty simple functions. We just save file about the GPS statistic and top student information into a text file. First, we need the file's name right here, and then we just get the average mean of GPA, and then we just get the total number of students, and then we open the file with the writing type to writing the file and get the txt file, as you could see right here. Yeah, the summary text appeared, and you can see the total number of students, average GPA, and finally top student. And now to the last part, we're just combining all of the menu together. First, this is a menu page right here. This is our main menu here, right here. And then the graph menu, which is once we type to see the graph, the interface will change a little into the graph menu, and we could go back. And then we just and then we finally finish it. The last part is to combining of it together. When we run main functions or pressing the play button right here, we just read file and run the menu functions and keep going and going. So that's it for our final project, student data. Thank you for your attention.